What's up, y'all? Today we are going to be looking at La-5. Let me just real quick do this. So I am working in our studio. I highly recommend doing this. I have created a little PDF on Canvas. It should be under course materials. It is also likely in the announcements. How to download R in R Studio should only take a few minutes, so go ahead and do that if you'd like. If you're having troubles, especially with Posit Cloud. So next things, we're gonna go ahead and get started on this assignment. So make sure you create a header with your name, the assignment, date, and class. And then we're going to install and load our packages. This little pop-up is not bad. It's just asking if you want R to update the loaded packages because they already are existing in your environment. But I go ahead and click yes most of the time. So once I have installed and loaded packages, I am going to start. Another note, if you are using R in RStudio, you need to set the working directory. So the way to do this is to navigate to your work in the file section down here, and then click save, set as working directory, and then at this point it will be set as your working directory, but then I like to copy and paste this up here. Cool. So next I am going to read my .csv files into my environment as data sets. So using the read.csv files that we learned about last week, you go ahead and in quotations find the .csv files that you've downloaded off of Canvas, and then bring them into our environment. So now I can read this data in a few different ways. I could use the glimpse function, I could call the data set, or I can click the name of the data, which is helpful because it'll pull up a new little tab in your R script section, and you can easily bounce back and forth if you're looking at what the data is representative of. So the first question is asking us how many wind turbines are located in New Jersey, and then how many wind turbines became operational in 2019. So a couple quick ways to do this. I can either just use the frequency function as a whole, which will show us all of the states. Navigate to New Jersey. The frequency is 6. But then another way I could do this, I could filter for just when the site state is equal to New Jersey, and then when I run the New Jersey data set, I'll find that the frequency is just 6. So the way I did that, created a new data set called New Jersey assigned to the WT data set. Then I filtered for when the site state is equal to New Jersey, and then I did the frequency of the site state. Similar to that, when we're looking at the years, we could look at the frequencies of the years as total, find 2019, find what that is, or we could filter out the data for when the year is equal to 2019. And then we have to call the function, and then we see that is the same. What percentage of turbines became operational between 1983 and 1990? The quick and easy way to do this is just to look at the percent total accumulation column that is part of the frequency function. Scroll down to where it says 1990, and then you can see the 1.8042. I have created another video which shows you guys maybe a cleaner way to do this using more functions. That should be already put into, I believe, week 6 module, but whatever one this one is also included in. Another way for the next question, it's asking how many turbines have become operational since 2000 in New Jersey. So I'm going to create a new value called New Jersey 2000, assigned to the WT data set, then filtering out the year of greater than or equal to 2000, and then filtering out the site state is equal to New Jersey, and then using the nRow function to count the total amount of rows, which should be 6. Cool. And then when I call the value into my console, I should find 6. So now we're going to move on to this next section, the turbine capacity. I'm going to go ahead, instead of filtering out data, which you can, if you decided to filter out the turbine capacity is equal to 2300 kilowatts, you could do that here, but I am not going to. I'm just going to look at the data as a whole. I'm going to navigate to where it says 2300, and then I will find the frequency is 6319. That's how many turbines in the subset have that capacity. The next question is asking the percentage of turbines that have the capacity of 1500. Here I'm going to look at the percent total accumulation, and then when I navigate down to 1500, I can see that there should be we're not going to look at the total percent. We're going to look at the percent valid. Sorry guys, my apology. We should find 16.8681% at 1500 kilowatts. Cool. This next question is asking us to examine the descriptive statistics for turbine total height. To do this, I am going to start with the WT data set and then look at the variable of turbine total height. When I run this, I should get this nice, neat mean, min, max. But another way we can do this in the description function alone is using the money sign, looking at the WT data set, and then and then looking at just the column of turbine total height. So when I run that, I should get the same thing. This next section, we're going to be looking at the mutate function. Is asking us to create a new variable called turbine space that is the mean of the two existing variables, turbine hub height and turbine rotor diameter. So for this, I am going to create a new data set called WT2, assigned to the data set of WT, and then creating a new variable called turbine space using the mutate function that is assigned to the mean of turbine hub height and turbine rotor diameter. And now when I create this and run the description function again, I should get a nice, neat little mean, min, max. So just backing up a little bit, when finding the mean or an average, make sure you divide the sum of the total amount of variables that you're looking at by the total amount of variables you're looking at. So in this case, turbine hub height is 1, turbine rotor diameter is 1, that's 2, so dividing the sum of these two objects by 2 is how you find an average. All right, last section. So we are going to recode projects with 90 turbines or less into a low category, and those that have 90 turbine or more than 90 turbines into a high category. So we're going to do that using the case when function. And so I'm going to create a new data set called WT3 from the existing data set of WT, and then I'm going to create a new variable using the mutate function called project number, which is assigned to low if the project number of turbines is less than or equal to 90, and high if the project number of turbines is greater than 90. So now when I run that and then look at this nice little table for project number, I should find high and low the amounts. I could also choose to do it this way. Instead of using that table function, I could create a new value called low count, which is assigned to the WT3 data, and then filtering out for just the low project numbers, and then counting the amount of rows in my data. And then when I call the value into my console, I should find the same number as the low, and then this is the same process for the high count. Cool. I hope this made sense. I'll do more videos like this in the future. Let's quickly look at how to save it in R Studio. So this process sort of is the same as POSIT Cloud, so click Save. Make sure you're using the system default. La-5. Oh, yeah. Okay. So now when I save that as an R file, I should see it down here in my files section. I will then, this is now done and it is in your file. So if you navigate to your work, you should be able to find the exact thing that you created. But remember, if you're using POSIT Cloud, you need to export this. So you would check the box next to the saved file, click the setting wheel, and then click the export button, which is not here because I'm in RStudio, but if you're using POSIT Cloud, it should be there. So cool. Well, I hope you guys had a good break. I know I did. Yeah, I'll catch you guys later. See ya.